These percentages present a situation that involves one more step. It doesn't occur until we get to the fraction side, so here goes. 52% is 0.52. Switching, we're going to have 34.34 for our decimal. In this case, we will have 4.35. Taking our decimal from the very end, moving it over 2 places gives us 37.18. In this case, coming 2 places over, we're going to need a 0 here, so this would be 0.092. Because it goes 1, 2 over. And our 60 would just be 0.60. All right, now when we go to our fraction side, everything's okay so far. It just followed all the rules that you were used to. 52 is a fraction, so we're going to put it into our numerator. The 2 belongs in the hundredths column. But this is a reducible fraction. According to the rules of divisibility, both the top and the bottom, both the numerator and denominator, are even numbers. So you know that 2 is going to absolutely divide evenly into both the numerator and the denominator. So 2 divides into 5 2 times with 1 left over. 2 divides into this 12 6 times. And 2 divides into 100, 2 divides into 10, 5. 2 divides into 0, 0 times. We still have 2 even numbers. This can be divided again by 2. 2 divides into 2 once. 2 divides into 6 3 times. And 2 divides into 50. Okay, 2 divides into 5 2 times with 1 left over. 2 divides into 10 5 times. Now we say, are they even? No. Zeros or fives? No. Twin double digits? No. Will 3 work in this? Well, if I add the digits, I get a 4 up here, so that won't work. 3 will not evenly go into 4. 7 won't work. In fact, 13 is a prime number, so the only thing that will go into 13 is itself, and 13 will not go into 25 evenly, lowest terms. So this is the absolute fraction that we would want. 34, the 4 is in the hundredths column. Again, both of these are even numbers. So 2 is going to work. 2 goes into 1 one time, or I'm sorry, 2 goes into 3 one time with 1 remaining, and 2 goes into 14 7 times. If you took 2 into 100, of course you would get 50. Half of 100 is 50. Are they both even? No. Zeros or fives? No. Twin double digits? No. Will 3 work? Well, 1 plus 7 is 8, and 3 is not going to go into 8 evenly. 7 doesn't work. In fact, 17 is a prime number. So the only thing that could possibly go into 17 is itself, but that won't go into 50 evenly. So here's our lowest term fraction. We're just using our rules for divisibility in order to reduce these fractions to lowest terms. This time we have a whole number. So this comes over here as 4 and 35 hundredths. In this case, 35 and 100 both end in a 0 or a 5. So we are going to be able to divide this by 5. Drag our whole number over. 5 goes into 35 7 times. 5 divides into 100. 5 divides into 10 2 times. And 0. That is our lowest fraction, lowest terms fraction. 37 is a whole number. 18 is our numerator. The 8 is in the hundredths column. Both are even numbers. Let's drag our whole number over so we don't forget it. 2 divides into 18 9 times. 9 times 2 is 18. And 2 divides into 150 times. 92 thousandths. All of this is the fraction, so 92 is the new numerator. Again, they both end in even numbers. So 2 will work into this one. 2 divides into 9 4 times with 1 left over. 2 divides into 12, 6. If we go 2 goes into 1,000, 2 goes into 10, 5. Okay, so it's 500. Both still even. We can divide again by 2. 2 divides into 4 twice. 2 divides into 6 3 times. 2 divides into 5 2 times with 1 left over. 2 divides into 10 5 times. 2 divides into 0 0 times. They're not both even. They don't end in a 0 or 5. No. Twin double digits. No. If we add the digits, we're going to get 5, and that won't work with a 3 or a 9, and 7 will not go into 23 evenly. 60 is a complete fraction. It's on the decimal side. It's on the fractional side of it. The 0 is in the hundredths column. Both of these end in a 0. We can divide this by 10. We would get 6 tenths. Now both of those are even. We can divide by 2, 3 fifths. So that is our lowest term fraction. So once you get finished with switching the columns, the fraction, you have to think back to your rules for improper fractions and simplifying the divisibility rules for simplifying fractions that are not improper, but could possibly be reducible.